So let's talk about how we do dilations with the center not at your origin, right? So here we have this wonderful formula that we're going to try and put into use here in a second. And then if it's too confusing, well, then we're just going to scrap it and just count, because counting is pretty easy. So let's see what to do. Okay, we have a scale factor of 2. That's your K value. And your center of dilation is -4 or 6. So this is your A value, and that's your B value. Okay, A and B. So let's try and do this formula or the notation with point A. Okay, let's do it down here at the bottom. So we have, let's figure this out. Our A value is -4, right? So -4 goes here. Plus 2, the K value, your scale factor, times x minus A, which is -4, so x plus A. Okay, and then the Y value is B, so B was 6, plus 2 again, because that's your scale factor. Y minus the B value, so Y minus 6. Okay, so let's see if we can do this algebraically before we talk about how we do it non-algebraically. So -4, 6 is the point way up here. Here's your new origin right there. Okay, -4, 6 is your new origin. So here's your new axis. Okay, so we could do something like we did with the other style of rotations, and we can make this our 0, 0, and take all of your points from here, which is a perfectly grand way to do it, in case you don't remember this formula, by the way. But let's see if we can use this formula for at least one point. Okay, so here let's do A. A is at the point 1, 4. Right, 1, 4. That's your A value. So to figure out what our new coordinate is, we do -4 plus 2 times 1 plus 4. Right, this is your x. So 1 plus 4 is 5. 5 times 2 is 10. -4 plus 10 is 6. So there's your x coordinate. Okay, and then your y was 6 plus 2, y minus 6. So that's, let's see, we have a y value of 4. So 4 minus 6 is -2. -2 times 2 is -4, so the y value should be 2. So 6, 2 is where we would anticipate having A prime. So, if you don't remember that formula for some reason, I don't know why, let's see if we can do this another way. Okay, let's do it the counting way. So, if that's my origin, how far horizontally and vertically is point A away from that origin? That's what we're going to ask ourselves. So, we're going to count it. It is 1, 2, 3, 4, 5 units to the right, and 2 units down. Okay, so A is at 5 and 2. 5 right, 2 down. So if I want to be twice as far away, I'm going to have to double both of those directions, right? I have to double my horizontal distance, and I have to double my vertical distance. So that means I'm at 6, 7, 8, 9, 10. This is 10 units away from my origin. And 1, 2, 3, 4 units down. And look, I get to the same point as I would have had a second ago, doing all those calculations. Okay, so my brain doesn't really do calculations very good all the time, but I can count pretty awesome. Counting is what I'm good at. So let's count point B. B is 1, 2, 3, 4 down and 2 right. So 4 down and 2 right, and I'm going to double that, so I go down 8 and right 4. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. This is where B prime would end up. I'm sure it would be the same if I looked at that formula. And C prime is 1, 2, 3, 4, 5, 6 right, and 1, 2, 3, 4, 5, 6 down. C would be at the point 6, -6 if we were using this as your new origin. So then I'm going to go 12 right and 12 down. So there's 10, 11, 12, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I am just counting how far, right, how far horizontally and vertically are each of my coordinates away from my quote-unquote origin. Right, the origin in this case is the new point at -4, 6. Okay, so this is a dilation of our triangle where the origin was not the center. Okay, it's a new place, right? It's not the 0, 0, but -4, 6. And we do it by counting. We're just going to count how far do we have to go. Okay, so let's try this other example over here and see if we can make the same kind of sense of it, right, without worrying about the notation. So here we have our center of dilation at the point 5, -5, which is way down here. So there's the point 5, -5. So this is our new origin. Okay, we're going to call this our origin. So we're going to put in your x-axis and your y-axis. And we're going to count from there. Okay, we have a scale factor of 1/2. So we're going to divide all of our distances by 2. Divide our distances by 2. Let's see where that puts us. Let's just do B. B is pretty easy. B is 1, 2, 3, 4, 5 units above our orange dot, which means B prime is going to be 2.5 units above our orange dot. C is 1, 2, 3 left and 2 down. So it's going to be 1.5 left and 1 down when you divide both of those distances by 2. Okay, D is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and up 2. So 5.5, because that's 11 divided by 2. 1, 2, 3, 4, 5.5, and then up 1. Puts D prime right there. And then where is A? It's off the page. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 up. 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left. So half of 14 is 7. 1, 2, 3, 4, 5, 6, 7 right here. And then what is it, 9? So 4.5 left. 1, 2, 3, 4.5 puts me right in there for A prime. Okay, so I'm sure that formula would have given us the exact same coordinates as what we got by counting. So if you love formulas, by all means, use that fantastic notation formula. Okay, just make sure you memorize it for your entire life so that when you're 75 years old, you haven't forgotten it. Just kidding. That's what formulas are like. So if we can find another way, aka counting, that always works all the time, no matter what your age is. Okay, only we don't have the notation, and I'm okay with that. Okay, so that's how we do a dilation with the center not at the origin. Okay, we count from our new place and use the scale factor.